Welcome back to Maths with Mrs. J. We've been doing a series on what I refer to as basic trigonometry, which is trigonometry of right-angled triangles. It can actually get quite complex in some of these questions that we're going to get into in future videos. We are going to deal with some situations where we might have three-dimensional problems and that sort of thing. However, for now, I just wanted to teach you how to do the problems when you're finding the angle. Let's have a look at this. We're going to start off in exactly the same way as we always have been. So we're going to label our sides accordingly. Now, this is a Greek letter alpha. Don't let that put you off. It's just like an A, a B, or a C. In fact, it's the Greek letter for A, all right? Because we're finding the angle, we need to have a look at what sides we've got in relation to that angle. Now, this side across here, goodness me, why is that doing that? This side across here is our opposite side, opposite the angle. This side here is our adjacent. So as always, we're going to start off in the same way, whether we're finding a side or whether we're finding an angle. We label any sides that are relevant. Then we think about our rules and we work out which rule is appropriate. The rule that involves the opposite and adjacent side is the tan rule. So we're going to write down our rule. All right, now we're going to substitute. Now in this case, theta, we actually don't know what theta is. It's actually alpha. Okay, so opposite is 2 centimetres, adjacent side is 8 centimetres. Now, what are we actually asking for here? What we're actually asking for is what angle has a tan of that? So if I did tan of what angle in degrees would give me our 2 divided by 8. Now, what you do on your calculator is you do an inverse tan. And I would actually just do 2 divided by 8 equals and then do inverse tan, or do inverse tan and then use your brackets. Your inverse tan should be above your tan button, and you will probably need to use your second function button to access it. So I wouldn't work, I mean, this one here is obviously only 0.25, so you're not getting any inaccuracies anyway, but I would go straight to this step here. Then I would use my calculator. And rounding off to 2 decimal places, you get 14.04 degrees there. All right, let's proceed. So again, where's our angle and what sides do we have in relation to it? Well, this is our opposite side. And this is our hypotenuse. Which rule involves opposite and hypotenuse? The sine ratio. That is correct. So your sine of your angle is opposite over hypotenuse. Theta is actually theta here. I've kept it the same. Opposite side is 12. We don't need the meters if they're both meters, so that's okay. And hypotenuse is 15. So theta is going to be the inverse sine of 12 on 15. What that's doing is that's saying what angle has a sine of that. So if you do that on your calculator, you should get 53.13 degrees to 2 decimal places. Okay, let's proceed. All right. Same process as always. In relation to our angle, this is the adjacent side. This is your hypotenuse. Which rule are we going to use? Cos of theta is adjacent on hypotenuse. Subbing in, this is the Greek letter beta. Adjacent is 5, hypotenuse is 7. We're doing the same sort of procedure as we did in the previous examples. We're sort of like undoing the cos. We're saying what angle has a cos of that? So we're doing inverse cos of 5 on 7. So using our calculator and rounding off, we should get 44.04 0.42 degrees approximately. Last one for this video. This is a Greek letter phi. This is your opposite side. This is your adjacent side. Clearly, we're going to use tan. Tan of theta is your opposite on your adjacent. So tan of phi is 3.1 on 5.7. So phi is the inverse tan of 3.1 on 5.7. Now, because this is our last one for this video, I'll talk you through the calculator part of that. Make sure your calculator is in degrees for starters. Then you're going to find your tan button. You're going to do second function tan, and then probably will come up a bracket. So then you're going to do 3.1 divided by 5.7, and you're going to close brackets, and then you're going to press enter. And that's going to come out to be 28.54 to the nearest, well, to 2 decimal places. Now, this is the end of the series of videos just for now. However, we will be doing more videos with right-angled triangle trigonometry. We'll be talking about some problem solving, some three-dimensional problems, angles of elevation, angles of depression, all that sort of thing. So look forward to those coming up, but for now, that should keep you quite happy and quite busy.